in some of the things that I teach at the Harvard Extension School. I currently teach 3 courses, one every semester. One is Mindfulness, Meaning, and Resilience, and a couple of you have been in that class before. We have a veteran, actually, who was here in the first time, Andrea O'Hearn, who was in our 2014 group. So, so there'll be some new information since then. Nice to see you. And also in the spring, I teach a course called Compassion, Science, and the Contemplative Arts. It's a fairly new class. And what I'll be covering tonight is kind of a bit of a summary from some of the things that we cover in those 2 courses. The summer class I teach is on the science and practice of mindfulness, and it's for high school students in the Harvard Extension School, the pre-college program, which is always a delight to work with teenagers and adolescents who are surprisingly well educated and intelligent about all these subjects we're going to talk about tonight. So I always have to be on my toes with them. Anyway, so anyway, I'm going to share screen here. Let's make sure this is all working, and we'll get going. Okay, that's not the view. There we go. Okay, so the science and science of meditation and compassion. Quite interesting topic for anyone who is really interested in diving into what we actually know empirically, and also in many ways theoretically. A lot of the research that has been done through things like functional MRI, EEGs, PET scans around brain activity and meditation um, actually have been done for a long time. Actually, since as far back as I know, in the 1970s. Um, and along with increasing technology and research into things like neurocardiocytes, these are neurons in the heart that are very much impacted by the nervous system and stress and such. A lot of new terrain that we are consistently kind of realizing and recognizing, and also things around the physiology of compassion and loving kindness, not just mindfulness. So we're going to sort of skim the surface of the literature tonight and begin first by looking at stress, looking at stress. So we're going to start there because I'm sure many of us on this call have at least some measure of it right now. And if it's something that has come from our day, from our lives, there may still be sort of an after effect of the stress. And perhaps the stress is forward looking. It may be projected into the week ahead and so on. What we're going to do is pause a moment, find that space in between yesterday and tomorrow, the past and the future, and create a space where we can kind of look at these things in the present, and then see kind of possibly where we fit in our own meditation practice. So we're going to begin with a book that I read back in, I think it was 1989, by a psychiatrist named Hans Selye, who wrote sort of a definitive book on stress. All the way back in the 1950s, the book that I read was called Stress Without Distress. How on earth do we do that? After all, he was not a meditator, apparently, at least as far as I know. So how does that work? And I think what's notable about his theory and his research is that stress is not just an experience or an event we're having from the outside. In other words, it's not just an external event, that which causes us stress, but rather it's our response to that event that dictates the degree of stress that we experience. Yeah. So this is not to lay blame or to say it's your fault if you're stressed out, but rather the sort of the mechanism of stress is largely has to do with our perception and our sort of our own internal experience of how we're relating to what happens to us. So that was a new thought back then. It was an area in which we began to realize that stress is really something internal that ultimately began to lead to more research around things like biofeedback and ways that we can downregulate our own arousal in the nervous system when we are under stress. Now, he also said that some stress is healthy, that not all stress is bad. In fact, many of the good things in our lives, the exciting things, are also stressful. They're also stressful, and but that doesn't mean we need to avoid all stress. The key here is that short-lived stress actually is good for the physiology of the body. In a way, it kind of works out our hardiness, what some have called psychological hardiness, by kind of using the mechanism of stress response and then returning back to homeostasis, returning back to a balanced state. And we'll look at homeostasis in a moment. So some stress is actually good for us. It keeps vitality going. It keeps kind of all of our mechanisms in a way, like the immune system has to be made healthy. Sometimes a little cold isn't a bad thing, right? Because it kind of engages the immune system and keeps it active. So what is that mechanism then within us that responds to stress? That is the sort of the core of our physiology. Now, we have these various nervous systems that are actually quite intertwined with each other and very much interrelated. We have this thing called the central nervous system. So for some of you who are science majors or have a background, this may be review, but we're going to go quickly through these ideas. The central nervous system largely consists of the brain and the spinal cord. Yeah. And so this is largely kind of the largest system that then has offshoots of ganglia and nerve fiber bundles and stuff that move out into the various other regions of the body. And some of these processes are the peripheral nervous system is also sort of the next kind of largest corpus of nerve pathways and nervous system, and that is made up of two others: the autonomic nervous system, which is largely reflexive. It's largely automatic, and this is what happens when we are under stress. And then the somatic nervous system. And we're not going to talk much about the somatic nervous system, but largely that has to do with body awareness, the physiology of muscular responses, and those kinds of things. But the autonomic nervous system, this is where the goods are for tonight, and it's largely seen to be involuntary. And the autonomic nervous system is comprised of two sort of subsets of nervous systems. One is the sympathetic nervous system, and the other is the parasympathetic nervous system. And actually, there is another one called the enteric, and we're not going to go there, but largely that has to do with the gastrointestinal processes of the body and so on. And interestingly, just a note about that is that within the GI system, this is thought to be a second brain because there are neurotransmitters there. There's our immune system is there, and stress impacts that part of the body quite strongly because of that, as well as the heart area from this new field of neurocardiology. But the sympathetic nervous system is that when somebody claps their hands too loud, or you step off the curve and a bus is coming, and you realize, oh my gosh, I could get killed, I better step back. And it's that part of us that is reactive to a stressor, and it happens very quickly. So we all maybe perhaps know what this feels like. It's the stimulating aspect where we may experience a fight or flight quality or freeze. The second we realize there's a threat, the sympathetic nervous system kicks right in, and the cortisol in the blood sugars increase dramatically, so that we can act. We have energy to react to a stressor, and the heartbeat speeds up. We're basically being prepared to react in some defensive way. And this is automatic. You start to sweat, maybe you get a little shaky. Now, the part that we call the parasympathetic nervous system is that part of us that seeks to regulate those effects of the sympathetic nervous system. Yeah, and so although the sympathetic is involuntary, the parasympathetic says, "Wait a minute," and this too is involuntary, by the way. It seeks to maintain some equilibrium so the heart rate doesn't get too fast, so that the blood flow to the brain isn't cut off entirely, which is sometimes why people faint when in moments of extreme panic or extreme fear. And we'll talk about that in a moment too. We'll be looking at the vagus nerve. And this is not a gambling reference, mind you. This is an actual thing that we all have in us right now. Um, so the parasympathetic nervous system, the function here is to conserve energy and to balance out the heart rate, to bring the blood sugar back down so that we are actually finding a state that we call homeostasis. And largely, it's an equilibrium. It's a state of equilibrium. So here you can see just these various terms. The sympathetic nervous system we can see as being reactive. It's the reaction part to stress. It's also that which we experience if we're having a panic attack or anxiety. The difference being here that the fear is what we might call maladaptive, or it's something that arises from some kind of imagined threat that may not be real. Yeah? And then the parasympathetic nervous system is that regulatory balancing function where it seeks to sort of slow us down a bit. And homeostasis is that state of balance. It's that equilibrium between these systems. It's what we would call sort of biological or neurobiological functioning is now sort of at a baseline state. Yeah. And the process of adapting back into a homeostasis is called allostasis. This is a process of regaining homeostatic balance as we adapt to the stress that we're in. Now, great. So bus was coming down the street. All these things happened that we just talked about. I was able to jump out of the way, and I'm feeling a return back to some sense of normalcy. Yeah. I go back to singing my Satipatthana song in my head that I'm writing, whatever it may be. Now there is this other term called allostatic load, and this is a bit more problematic. And this really is where chronic stress over a period of time begins to act on the body and mind, act on the nervous system, and the equilibrium, the functioning between the nervous system, the immune system, the endocrine system, and on and on. And so allostatic load is a term that refers to the wear and tear on the body and mind due to chronic stress. So this is where we get into what we might call chronic stress. Yeah. Now here is this lovely nerve called the vagus nerve. It's also known as a pneumogastric nerve. It's the largest nerve system in the entire body, single kind of nerve system. You can see here in this image how it begins here in the brain and then travels all the way down. It actually goes even further down than the bottom of the picture. So it travels throughout the length of the body and spreads out a bit around the organs. And it's largely linked to breathing and is a regulator of stress responses, reactions to threats, as well as sort of constricting or contracting the blood flow to the brain. So I know somebody who faints when they see needles. You know, if they get blood taken or they're going to get a vaccine, God forbid that happened during these times, but they really have a rough time with it and they do faint. And so I told him, I said, you know, one of the things that's helpful to do, there are ways to kind of downregulate that extreme sort of reactive reactivity in the vagus nerve. There are things that can downregulate that arousal in the vagus nerve. And we actually, those of you who come to Marty's Dedicated Life Institute on Wednesday nights, we all begin with sighing. Actually, or do we begin with yawning? We begin with either sighing or yawning. We do both. We begin with yawning, actually, I think is the first thing. And interestingly, the act of yawning, of simply giving a really good, wholehearted yawn, and we've done this occasionally on our Sunday nights, has the effect of actually softening the contraction of the vagus nerve. It actually lessens the stress response there. As does sighing, a loud sigh. We've done this too occasionally, where you take a deep breath and you sigh all the way out. And so there are these ways that we can actually feel an immediate response in the vagus nerve simply by exhaling in a deep, deep way. And it does have an effect on the vagus nerve as well as other energy pathways in the body. And then there's this term called vagal tone. Vagal tone is basically the state of your vagus nerve, right? It's the state of balance between the arousal and a state of calm. So, put in terms of the nervous system, between the sympathetic and parasympathetic, we can find sort of a vagal tone, a quality where we are in equilibrium or out of equilibrium, as many people are these days. Another interesting part of a lot of this kind of biology has to be involves what's called the Hpa axis. These three very key gland part of the endocrine system, the hypothalamus, which is in the middle of the brain, the pituitary, which sits just below it, and then the adrenal glands down, sitting on top of the kidneys. Now here in this kind of very faint, transparent image here, we can kind of see here. There'll be a clearer image of this in a moment. But the hypothalamus, if you see this image, is sort of right here in the middle of the brain, and the pituitary gland sort of is an offshoot of that here. And these are in dialogue with the adrenal responses in the body that respond to stress, that release cortisol and other chemicals, adrenaline and such, blood sugar, so that we can actually act in a moment of threat. And the way to think about this is that the hypothalamus is kind of that receptor of information from the other parts of the brain. It takes all this information, kind of aggregates it to know what needs to happen next. And then, as sort of the CEO of the company, it will tell the pituitary what to do next. It will tell the pituitary, here is what needs to happen. And so the pituitary will then communicate to the other systems of the body and to the adrenal gland what kinds of hormones need to be activated, what needs to happen in the body. This will be interesting in the moment when we talk about visualization meditation, what I call the visualization chain. And I don't think has been researched nearly enough, but it is very interesting to think about how the brain uses a visualization practice to actually institute change in the body. So back to allostasis and homeostasis. Basically, Hans Selye said that our survival depends on allostasis, which is, again, the process of returning into balance, and the state of balance of homeostasis, the physiological adaptation to stress. Yeah. And again, overwhelming stress is that which is prolonged. And it can be both external due to situations, or it can be internal. And this is what erodes our adaptability to further stress. So you can see almost like a wire that starts getting stripped. It becomes more and more raw, if you will, over time. And so we're the same way. And this also impacts immune function and leads also to inflammation in the body. So he was a pretty, at his time, I think he really explored kind of these relationships and what happens to us in our experience and also in the body. Now, here's another interesting thing that Selye, as well as others, more recent people have researched and talked about. John Kabat-Zinn, Martin Seligman, the positive psychology guru, if you will. And that is that our perceptual field really determines how much stress we experience. So this goes all the way back to Selye, that it's not just the external event, but it's actually our relationship to it that really causes us stress. And we're not going to worry about these last two sentences. This is something I forgot to take out that is part of the questions that we ask our class. We can sit with this too. And what does our perception of a stressor say about resilience? And I think what we might do on a separate evening is talk about this field of resilience in positive psychology, something that I've looked into around resilience, something called affective traits, which are not feelings, or rather, they're not emotions or moods, but they are deeper feeling states. Anyway, those I think are very key also to stress and how we perceive things. But we're not going to go there tonight. Largely here, the the point that these thinkers talk about is that we have choices in how we see things. So it's meaningful. It matters how we perceive things and what our perceptual field is telling us about events that occur. And thus, how do we see ourselves in the midst of the stressor? And so here we start entering into the world of meditation and mindfulness now. The view that all the way back to the Buddha and his teachings on mindfulness in the Satipatthana Sutra, that have to do with how we are experiencing these various dimensions of our sort of embodied life. Yeah, how our perception, first getting to know our perception. So, in the text, he writes, know whether you are having a feeling. Is it pleasant? Is it unpleasant? Is it neither pleasant nor unpleasant? Yeah, is it neutral? Is it a worldly feeling? Is it an unworldly feeling? This is the language that he uses. And by unworldly and worldly, he means unworldly being something that is sort of taking you out of the suffering state and into a place of well being. So he kind of breaks it down into those two categories. And so Richard Lazarus, Lazarus and Folkman have written about this, have done a number of studies on the relationality of our relationality with the environment and our experiences of stress, and that mindfulness actually has an impact. Yeah, it has an impact on how we experience stressors in our environment. The teachings now on mindfulness that some of you have heard me talk about over and over and over again are broken down largely into four categories in the Satipatthana Sutra. So this text by the Buddha was written around his 10th discourse, after sort of emerging from under the Bodhi tree, the enlightenment tree. And he basically invites us to look at our experience on four different levels, the first being body. And interestingly, looking at this through the physiology of the body, not just the awareness, the cultivation of a sense of open awareness within the body, which is kind of the point of mindfulness, but bringing it back a little bit further into the gross level, of course, involving breathing and breath, which has that neutralizing capacity of the sympathetic nervous system, that through our breathing, we can intentionally regulate this balance between these two, what might be considered involuntary systems. Yeah, it's not so involuntary anymore when we're able to use what we call the somatic nervous system to intentionally cultivate a sense of equilibrium. So breathing is a part of that. The Buddha teaches us, breathing in, I know I'm breathing in long, breathing out long, I know I'm breathing out long. Attuning to the senses. What are the sensations that I'm feeling as I breathe? Am I noticing the changes? We know that breathing all the way back, also when the studies with biofeedback were being done, that breath is key to find and experience, actually fairly quickly in some cases, a nice balance between the stress response and the calming response here. Otherwise, allostasis and homeostasis. The other aspects of the body section of this text involve meditating on the four elements: earth, water, fire, and air or space, and how these things also impact the body. Largely, meditating on the body as having these four qualities, as well as relaxing, doing progressive muscle relaxation, the body scan, that really begin to change how we experience the body when we're in an aroused state. The second category is feelings, and largely this is not so much emotions, but it's more, how am I feeling right now in this moment? Am I feeling agitated? Am I feeling peaceful? Am I feeling calm? Am I feeling compassionate? Or am I feeling just a sense of annoyance or irritability? And so part of this is he instructs us to become aware. What am I feeling? Is it a pleasant feeling, an unpleasant feeling, or neither pleasant nor unpleasant? Is it neutral? Yeah. And so basically getting to know what we might call decentering, decentering out of that feeling, and still experiencing it from within the feeling, but getting a perspective on it here. This perceptual field, this sense of mindful presence, is able to sort of explore and experience this feeling without being overwhelmed by it or being so identified with it that we can't see out of it. So becoming aware. Mind, again, um, focusing on the nature of our thoughts, what we might call decentering from our mental states or from our thoughts, meaning that we are able to bear witness to the thoughts without being caught up in the tide of those thoughts. Yeah. And then relying on the sensations of our breathing and coming to know the nature of our thinking as being so transient and impermanent that everything is constantly changing. But by establishing ourselves in a sense of open awareness, that we are able to kind of watch this flow of mind and not get into the tide. Yeah. And if we do get into the tide, we don't judge that either. We just simply recognize what is happening and bring ourselves back. All of these things impact our perceptual field, as Lazarus and Folkman talk about it. And then finally, the fourth category here, the fourth foundation of mindfulness, which are called dharmas or dhammas in the Pali, are insights. This is usually where mindfulness practice moves into vipassana practice, what is called insight meditation. And that begins here with the fourth foundation. And this is gaining insights into the truths about our experiences, as well as the nature of our mind, what is causing us suffering, and what is the nature of that which is not suffering? What is the nature of awareness itself? How is it that open awareness or a mindful state actually can hold all of these things? What is this experience like? We get to know impermanence, we get to know suffering, we get to know change, and also what is not us, the things causing us suffering. So these are largely, this is a broad strokes of the mindfulness teaching. And all of these have to do, I think, with impacting the perceptual field when we are caught up in a stressor. And we can go right into practice and consider that. How we're relating to each of those stages may impact then how we respond to what is outside of us. What is the cause of that stressor? And give us a way to do it. Now, as I mentioned earlier, this visualization chain is really quite interesting. So I've given it this name. There hasn't been much research done on it. And yet, if you start looking at the physiology of imagination and of visualization, we can see how visualization practice, such as meditating on the four elements, meditating on myself as a mountain, for example, or visualizing a fire down at the base of the spine, energizing me, filling me with warmth and love and healing, purification, or water moving through my body as clear water gently flowing, and so on. Or just mind as open sky, open sky mind, bright, clear, pristine, clear, and radiant. All of these forms of visualization, it's interesting, they do have a causal chain for why they can actually impact changes in the body. And so largely how this works in this is largely theoretical. This is certainly something that I've been kind of sitting with and putting together. But in the back of the brain, here's this image again of this sort of hazy person. There's this thing here in the back called the occipital lobe. Yeah, this is where what we call the visual brain is activated when both when we are watching things, when we are engaged in sight, but also when we close the eyes and we imagine things. The visual brain is still active. Now, what happens when the discursive mind, the mind sort of cognitive thought, of rumination, of concepts, concepts that we basically associate more with language, Yeah, the thinking mind begins to quiet down, and the visual brain, the images in the visual brain, the experiences of those things actually um, get larger. Yeah, we feel them more intensely, and the mind begins to quiet. This is very interesting because what we're doing then is we're bypassing this discursive mind, and the visual data, that is the inner visual data, we're bringing to mind an open sky, let's say. When the mind is quiet, when the mind is no longer a chatterbox about whether or not this is a real experience, when that quiets down, this visual brain is largely picked up, that data is picked up by the hypothalamus as an actual experience. And this is the same thing when we're dreaming, when we're asleep and we're dreaming. This is what is active. The visual brain is very active. And the hypothalamus is in these moments is taking in all of that information and then instructing the pituitary gland to adjust things in a certain way. And so this HPA axis seems to be implicated here in this visual chain. So let's say we are meditating on the body as being like clear water gently flowing, and we can actually visualize almost like a stream of water moving through the body, that every pathway in the body is opened by it, right? The muscles are softened and cleansed by it. Our cells are taking in this water and are being nourished and cleansed, and then expelling out anything unwanted, and then flushing that water out down through the feet, and then closing the feet and filling yourself up with water. So this is a healing meditation that I've done many times in my work with cancer patients. Um, and how the actual experience of doing this when the mind is quiet, you can really start feeling a difference in your physical body. You feel like you're in a different body. Yeah. So there's a reason for that. There's a reason why that happens. But we need to be able in those moments to relinquish sort of the discursive mind that is saying, this isn't real. I wonder if this will work or not. You know, kind of what we might call getting in our own way here, and allowing the practice itself to work us. Yeah. So very interesting. So here we are sort of just shifting a bit. As I said, these are some broad strokes we're looking at, and we can, you know, if you have questions afterwards, we can look more at some of these things. But there's this term called neuroplasticity, and largely the brain used to be seen as being hardwired. That you are the way you were when you were born, and you cannot change it. You cannot fix anything, yeah, in the brain. And we know now through decades of research by now that that is not the case at all. Change is very much possible. And as are the neural pathways in the brain, that those can be changed too. Now, that doesn't say that it's easy, but it is possible. And largely because of what we call neurons. And these are these cells that basically transmit chemicals and electrical impulses across gaps from one neural pathway to another. It's largely sending electrical currents across those gaps, which we call synapses, to the receptors on the other side. And when you have many of these chains of neurons and receptors, and they are kind of like flowing in a certain direction, so these become habitual through experience, through repetition. We develop these pathways by doing. This is also something that helps lead to change if we can understand what it takes to change something, as well as our own brain physiology in those moments. So a neuron is a cell, and the neural networks are these very complex pathways of neural electrical impulses and neurotransmitters that are interconnected, and they convey messages to different parts of the body, different processes. And so this is what is meant by neuroplasticity, and which is being researched intensively and has been for uh, probably a good part of 20, 25 years now. And part of what is interesting about change here, what does it take to change a neural pathway? What does it change to take a habit? And while we're at it, we might ask, what does it take to change our relationship to what we're experiencing in the moment. Now, there are three kind of recognized factors here to change the brain, and I've added a fourth, which I'll mention in a moment. But the first is repetition. If you do something enough and you do it over and over and over again, that you are actually, if you're, as long as you're doing it differently, you are actually creating a new pattern that actually impacts the brain itself. Yeah, it's not just this amorphous quality of behavior, but it actually has a physiological system. The second thing is intensity. So you can do something over and over again, but it's not really creating much of an experience for you one way or the other. Yeah. It may take longer. That's not to say repetition alone won't create a new neural pathway, but intensity is also a factor that the more intensified an experience is, the more you're going to sort of feel the fruits of that experience, whatever it may be. So think about meditation here. Let's say you practice 15 minutes a day, every single day, and every time you practice, it's just kind of neither here nor there. So you're going through the motions, but you're not really getting much out of the practice. At that point, I would say maybe try to sit for longer, not less, maybe more times during the day, and make sure you have a teacher, a good teacher. Um, but the other side of that, let's say you're practicing every day, and every time you practice, you settle in deeply, and it's almost like you are a sponge being dipped into this clear pool of water, and you're just soaking it in, and it feels good, and you arise off the cushion, and there is a real sense of change you feel. Those moments when you're noticing change already are important. And this is why when we meditate, even in the midst of our practice, we want to be open to the experience that we are changing. We don't want to analyze it or sort of get spun off into a narrative about it, but feel through your senses, ah, here is change. Here I'm breathing in. As I breathe out, I'm feeling everything unwind. There is change, you know? Wholesome change. And then the third is time span. How over a length of a certain time we can change patterns. We can change habits and patterns over time. I added now this fourth, vigilance, because we can repeat something, we can be intense, and we can do it over a period of time. But we also need a sense of devotion, or this could also be intention or motivation, yeah, or dedication, if you will. But it's a quality that keeps us hanging in there, and it's not that we're necessarily forcing it. It's certainly not from the standpoint of meditation, but that we are really devoted to what it is we're doing. Because if we're not devoted to it, how can there be discipline? You know, this word discipline, which comes from disciple or a devotee or being devoted to something. This is kind of the thing to look at. And if I'm not motivated and I'm not dedicated, then why not? And what is missing? So I'm not sure if Reuven and Gail are on here, but they would probably remember this picture that I have here. If you are, let me know in the chat. Um, there's another field that's very interesting, something called neurocardiology that I mentioned earlier. And this is a very new sort of field of research between neurology and the notion of homeostasis in the sympathetic and parasympathetic nervous systems, and the cardiac system, yeah, and then brain function, such as what we were just talking about with neurotransmitters um, and the HPA axis and so on. But there is this, and this all happens through what's called the Neurocardiac Axis. This is nervous system, heart, brain, and they're very complex interactive systems. Whoops, how did I get back here? And largely what they're looking at are the imbalances between sympathetic and parasympathetic nervous systems as they impact the heart and circulatory functions of the body. So if you start thinking about how meditation and mindfulness actually can help regulate these things naturally because of this neurocardiac axis, you're going to make an impact here on circulatory system, immune function. These things have been documented anyway. through research over the decades that meditation improves immune function and can even reduce inflammation in the body. Um, and part of what they're thinking is that these sympathetic and parasympathetic processes, stress responses, and so on, are also very much implicated in stroke, things like stroke, arrhythmia, heart disease, epilepsy, heart failure, and so on. So there's a real priority here, um, to kind of take into account how these things interact with each other. And interestingly, this last point, neurocardiocytes, this is a neuron that abides in the heart. This is sort of a very new field, as I mentioned. And these neurons are thought to seek to regulate all of these symptoms. Now, if they cannot, for whatever reason, if there is a dysfunction somehow, then you're really going to be helpless to these maladies that come, especially from stress. So, and it's also interesting to consider things like compassion meditation or loving kindness practice and how these actually might enhance the effect of these neurocardiocytes. So here, I don't know why I put this slide in this place, but it gives you an overview here of the brain. We have here the frontal lobe, which we're going to look at in a moment around the research on compassion and loving kindness, which is kind of interesting. The limbic core or the limbic system. Um, we have here, as I mentioned, the hypothalamus is almost a pea-sized gland here, and then the pituitary and the occipital lobe in the back. So what is it that researchers are doing? What are they focusing on? And what kinds of practices are they having their research participants do to find out a lot of these things? And as I mentioned earlier, fMRI, EEG, PET scans, largely things that monitor electrical activity in the brain and neurological functioning, what parts of the brains are highlight in certain things. Um, there's a neuroscientist who also is a meditator, and she has worked for years at MGH and been part of many of these studies. And I've often had her come and speak to my classes, although I think she's moved down to the south. So I haven't been able to hear back from her if she would come back to our classes. But nonetheless, she's been instrumental in compassion research, compassion in the brain through compassion meditation. And largely what we'll see by people like Davidson and Matthew Ricard and other people who've been very much involved in meditation research are these particular two forms, and that is FA and OM, or focused attention and open monitoring. Now, this is going to be very familiar because largely focused attention is very much, when you read the description of how they trained participants in their studies, they're really training them to do what we call shamatha practice. Shamatha in Buddhism is calm abiding. Yeah, training to keep your attention sustained. Um, and by in the practice of focusing on an object of meditation, the mind tends to settle on its own and calm sort of well-being arises naturally. And so here, this FA, it's recognized that there's more effort here because what we're doing is we're learning how to sort of regulate our attention, bring it back when it wanders. So there's a little bit of heightened activity in those regions of the brain where people are putting energy into focusing. Yep. And so it's really focused on practicing stabilizing your attention. The the open monitoring, we can say, is a lot more like what we would call vipassana or vipassana in the Tibetan. And largely, it's now beginning to see thoughts and emotions in interrelationship. We're beginning here to have actually look at how these things are interacting in our experience. So if I have a particular thought, how am I feeling that thought in the heart? How is it reacting in my physical body? Yeah. And part of the what they've realized here is that cognizance aspect of mind states involves an exponential increase in clarity by advanced practitioners of this open monitoring. There is a study actually that's very interesting where they used something called an attentional blink study, which is they had participants focusing on blinking lights. And whether they were doing the FA meditation or the OM meditation or OM meditation, it mattered. There was a second blink very quickly after one of the blinks in the series. So there'd be a blink of light, a blink of light, a blink of light, and then a blink of light, and a quick blink of light right after that, and then another blink of light. And what they found was that those who practiced open monitoring actually saw that second rapid blink. They actually saw it. The ones who practiced focused attention or didn't practice at all totally missed that second blink. There was a very large percentage of practitioners who didn't even see it. So what they were, one of their conclusions was that this practice that is akin to vipassana or vipassana means that our acuity of mind, our clarity, is heightened by practicing this. So it's not just stabilizing attention and well-being and calm, but then there is a clarity that emerges out of the practice where nothing is missed. So very interesting, I think. Loving kindness meditation is also something that has yielded some very interesting results in terms of gray matter in the brain, and particularly the frontal lobe, and in parts of the brain where empathy is cultivated or shown to grow by cultivating loving kindness, as well as compassion meditation. But the kindness and compassion meditations, which have been done for years by Sarah Lazar and her team at Mass General, at MGH here in Boston, have shown that there is this increase of gray matter, in particular in cultivating loving kindness. Some of the practices around compassion have also shown that, so in advanced meditators, where they were shown pictures of violence on a screen and measured their responses, and they measured them through EEGs, I believe, as well as EKGs, heart response, that kind of thing. And what they showed was a drastic increase in reactivity to the suffering. In some ways, they felt the suffering more than participants who were not meditators, but they also recovered from it much faster. So the effects were slightly more severe in experiencing empathetically the suffering they were witnessing, but their recovery and return back to homeostasis was much, much faster. So it's very interesting. Now, if you don't want to suffer, stay away from those videos, yeah? But very interesting how the resilience factor to overcome the bearing witness of suffering really made a difference here. So here are some of the studies. Gail DeBoards, the woman I was telling you about at Harvard, Lazar, changes in brain physiology, increased empathy, compassion, and self-awareness by cultivating loving kindness, and inflammation. They have found that compassion meditation reduces inflammation in the body. So that's very interesting. And it may be that this neurology and cardiology fusion are really able to explain a bit more, at least in an empirical way, how that works. How is it that sustaining your attention in mindfulness meditation and compassion actually reduces the inflammatory response in the body? And then there's this other neuron called a mirror neuron. We're not going to talk too much about them, but it's very interesting to think about in the context of empathy, how mirror neurons are simply neurons that are activated when we witness suffering. So in the case of that, the advanced practitioners in the compassion practice, it may be that mirror neurons were largely engaged and impacted sort of the neurocardiocytes possibly in responding to that. Anyway, mirror neurons, the things that when we see someone else feeling a certain way, and that acts as a mirror for us to feel the same thing or some approximation of it. Interestingly, Tibetan Buddhism has a notion of mirror mind. Yeah, I don't know that we can stretch those things together, but it is interesting to consider compassion from the standpoint of mirror mind being, in the Tibetan sense, that the mind is like a mirror, a clear, reflective uh, substance. It's not really a substance, but it has the qualities of utter clarity, and that the images reflected in that mirror are constantly changing, but they don't define the mirror itself. And so this notion of mirror mind being bright and reflective and clear, um, the fact that we can feel things, continue to feel things even more deeply in some ways through mirror neurons might be an interesting corollary to make. I don't know. I know Marty's on the call. He might be able to give us some insights there. Um, and we're getting sort of close to the end here, but hippocampus. This is a very interesting thing as well. So the hippocampus, it is not a school for pachyderm. It's not a location for them, but largely it is these two. These are not glands. They are actually made of gray matter, and the hippocampus is part of the limbic system in that sort of more central part of the brain. It is that part of us that retains emotional memories as well as positive memories, and it regulates emotional processes. So it sort of aggregates things together and makes some sense out of what we're feeling. And interestingly, when we're under stress, this hippocampus actually literally shrinks in size. So stress reduces the volume, the mass of the hippocampus. So it would make sense that under extreme stress, especially chronic stress, that we would be less inclined to feel empathy or to even experience sort of positive feelings as well as memories. Yeah. This is also implicated in learning. So if you're a student and you are cramming and you're under a tremendous amount of stress, it's going to be harder to learn in that condition than if you are experiencing well-being, mindfulness, and so on. But who can do that when you're in school, right? Um, and so interestingly, whereas stress reduces the volume of the hippocampus, compassion actually increases the volume of the hippocampus. This is very interesting. So this has been documented, and it is able to regenerate lost volume under stress, as well as reducing a sense of reactivity to the stress itself. So it's interesting what we're learning now about compassion and its impact on all of these systems in the brain and in the body. Um, okay, we're not going to go through these, so I want to be mindful of our time here. But anyway, there are these studies around compassionate responses to suffering. This is the study I was mentioning earlier, Condon in 2013, that was done, and also the study on lowering inflammation in the body by Pace and his team. So the last section here is probably one of the more interesting ones to me, and that has to do with brain waves. Well, what are brain waves? Huh? What are these things? There are these five types. First of all, brainwaves are something that people have measured doing studies in meditation, often focusing on the alpha brainwaves, this sort of sense of well-being, of calm, and so on. And yet there are other uh, implications of meditation on brainwaves as well, beyond just the alpha. And brainwaves are, you remember those little electrical impulses that were crossing the synapses in the brain from the neuron to the receptor? Um, a brain wave is sort of an aggregate of these waves that happens at a certain rate of frequency. So brainwaves are these electrical impulses between the neurons that convey messages. Many are habitual, largely are tendencies, pathways of consciousness, tendencies that we have that work in a combined way. So the frequency or the speed or rate of vibratory motion of brainwaves, um, that is what we are looking at when we look at these five categories. So, for example, the slowest is the delta brainwaves, and the highest are the gamma. And I always want to call them rays, not waves, because I remember Buck Rogers way back when, gamma rays. So if I make that mistake, it won't be the first time. Um, what we can do is, so here you can see, this is sort of a chart of brain waves. You can kind of see how these ones that have very large arcs that sort of move this way, these are the very slow, low frequency brain waves. And then the ones that are moving very quickly here are the higher frequency ones. And I think of it, maybe because I'm a musician, as a sort of a sound. Like it's very much like sound frequencies. You can look at it that the low bass notes are slower moving, and the very, very high tones usually happen at a higher vibratory rate. It's the same thing with brain waves. So the gamma waves are very quick. They're the fastest of the five. So the lowest, if we begin here with the delta, these brain waves are what are activated or generated, rather, when we are in a state of deep sleep. They are seen to be profoundly regenerative for the body. There is very little activity in the cortical layer, and um, in deep, deep relaxation, delta is pretty much the prominent wave that is active here, as well as deep meditation states. So people who meditate for long periods of time at a deep level, who reach the state of simply cultivating a sense of delta waves, often don't need nearly as much sleep as the rest of us, because they are regenerating so much in their meditation. Um, and qualities that are correlated here, interestingly, with the delta waves have to do, of course, with things like healing. So abiding in a delta state is an extraordinarily healing, regenerative way to be, as well as empathy. Deep state of profound empathy engages delta waves. That must mean it's a good thing, as well as connectedness, a feeling of being really connected with somebody else. Um, then we move to these theta waves, which are also considered low frequency, but a bit higher than the delta. And these too are generated in things like sleeping and dreaming. So when we're dreaming, we're not in a deep sleep where we are in just this deeply relaxed space. But now there is mental activity, creativity, imagination, learning, memory. These are all active in the theta states, as well as positivity. So when you're feeling really positive, there is this sense of settling into, or rather, generating these theta waves. And of course, again, meditation um, and visualization. So when we're doing a deep visualization practice, um, we are sort of in this realm of theta brainwaves. There is activity there. Yeah, we are visualizing, and we're sort of using the visual brain, possibly here through the HPA axis, to generate change in the body. And so it's not quite as static and as still, perhaps, as the delta waves. And then we move here into the alpha brain waves, which are more akin to wakeful states. When we are at ease, when we are calm, the nervous system is in homeostasis. We are alert, but we're also quiet, and there are flowing thoughts, a sense of well-being and contentment. This is why alpha brain waves have largely been the things that are measured in mindfulness studies. Um, and these waves also work with the body, with the brain, to produce serotonin as well. So when alpha waves are operant, we are relaxed, and this have been shown to lower blood pressure, heart rate, and also the production of stress hormones. So a very beneficial state. And actually, if we could live in this state all the time, we'd be feeling pretty groovy, right? We wouldn't need chocolate anymore, would we? So um, the other thing I was going to mention was the song that I played at the very beginning by Stephen Halpern, who's a musician who has calibrated those tones of Om to induce alpha brainwaves. So he's calibrated those notes in harmony to generate them when we listen to it. So anyway, I don't know if anybody felt different after hearing that song, but that may have been one reason. Now we move into a sort of a higher frequency, the beta brain waves, and this is what usually is the most active in our normal waking state when we are interacting with the external world. We are thinking, planning, there is conscious mental activity, we are doing, we are speaking, we are paying attention to a PowerPoint presentation on Zoom, we are concentrating, there is clarity. And the beta waves are also active when we are anxious, when we are experiencing sort of a sense of unease. And this is largely because it is an active state. It is an active, more active frequency. And so, there are sides to this, right? There is creativity and there is excitement as well as anxiety and so on. And so often beta waves will be generated by active response-based motivation. So when we're motivated or we're moved to do something or to react or to do to engage in some activity, we're working with beta as well. Now, I think how this might relate to meditation. This is more of a guess on my end. I don't know. I haven't seen any studies focusing on this. Maybe you have, but concentration and clarity. Yeah, that when we are actively focusing the mind, as we saw with focused attention meditation, and possibly in the open monitoring, that we are actually focusing on cultivating a sense of attentional balance, of sustained voluntary attention, and when the mind drifts and we know it has drifted, we just sort of gently bring it back into line. And that this intentionality in the practice may be important for our meditation, that beta waves are helpful to sort of maintain that kind of clarity and focus. And then finally, gamma waves are the highest frequency. This is also the one that has not been researched. It's sort of a mystery how this is produced, at least in the literature. And one of the studies involving Yongey Mingyur Rinpoche, who's a very popular Tibetan master who's written many books on meditation, a Tibetan monk, did a 2002 study where, using an fMRI, they measured gamma waves during him doing a compassion meditation, and the rate of his gamma waves were very elevated during that practice. Now, this as the fastest brainwave state, the processing from other brain regions and sort of gathering them together happens very, very quickly. So the other regions of the brain sending information, gathering together, and processing those things happens quickly. And this high arousal state in the brain generates gamma. Now, a heightened arousal here means something a little different than it did when we were talking about an aroused nervous system, like in the sympathetic nervous system. Here, it's just an acuity, it's a quickness of mind. It's an impression that we get things very clearly and very fast. What we've noticed with gamma waves are a decrease in depression. People who have highly activated gamma, as well as heightened feeling states and increased melatonin, is another sort of benefit. Healing, and these are also seen to be very pro-social. Some theories have posited that a heightened gamma, and maybe this can be borne by the Yongey Mingyur Rinpoche study in 2002, that insight and universal love and selflessness are all sort of implicated in these gamma waves. That when these are generated, we are able to function at higher forms of compassion, and by higher here I mean higher frequency forms. And so some think that the gamma waves are implicated in spirituality and spiritual insights and such. So this is an area that needs a lot more study if we're going to really understand this particular brainwave. And it wouldn't surprise me if there are subtler sort of forms of brainwaves that are even beyond what they've measured so far. I don't know. Maybe some of you have researched this more, but so that brings us to the end of the PowerPoint here, and we have a little bit of time left for anyone who's interested. I'm glad to see some of you are still with me.